Hi everyone, welcome back to our channel. Today we are going to do Matlab simulation on jet parameters. So we are going to verify the jet parameters for the Matlab circuit. So here you can see here the network is consisting of 820 ohm, 510 ohm as well as 2000 ohm. This is an 18 network we have. Okay. So for this we are exciting at input side and we are finding Z11 as well as Z22. Okay, and further we are going to do the same by exciting at input side. Okay, so here you can see the diagram. We are exciting at output port and we are making open circuit of input port and we are finding Z12 as well as Z22. So the theoretical calculation video, if you observe, this video will be very clear actually to what we are doing. So very simple to understand. In here, by making output port as short circuit, I2 as 0, we are finding Z11 as well as Z22. By making input port as open circuit, we are finding Z12 as well as Z22. A theoretical calculation video is there. So now let us try to see how to do the simulation. Okay, basically let's try to identify what are the elements we require. So we require three resistors, one voltage source, and one ammeter and one voltmeter, and let's try to connect. How to do the MATLAB simulation is just click on the MATLAB. Okay, so just click on the MATLAB, automatically a MATLAB window will be opened. So when the MATLAB window is open, at the top you can see multiple tabs. In one tab it will show simulation, start simulation. Click on the simulation. As soon as you click on the simulation, so go to the first block, which is nothing but a blank model. Okay, so now you'll be getting a blank model. So just enlarge it and keep it in the half of your circuit and minimize the original MATLAB. Okay, so now let us try to see actually what we need to design. Okay, so now this is what we need to design. So this also will minimize and we'll keep it in half. Okay, so now let us try to see here. So here first identify the circuit, what are the components we actually require. Okay, so when you see this circuit, to what actually we need to work out, you will be getting an clarity. Okay, so here you require three resistors. Okay, so first go to the library browser and click on it, and here you can see these browser elements. So in drag it down and you can see here, so here you are having multiple. So first go to simscape. Okay, so here you will be having multiple blocks, continuous blocks, aerospace blocks and multiple blocks. Just come down and here you can have one option, simscape. Click on the simscape. In simscape you click on the electrical, and this electrical you click on the specialized power system. This is how to go inside to the block. Now, so coming to the first, click the fundamental blocks. Here you require a default continuous system. That's why I'm keeping an continuous power GUI model, and we require some elements. Okay, so come to electrical sources. We require an voltage source. Let's try to pick up this DC voltage source and keep at the starting. Okay, and you require elements. Okay, so we require an series RLC branch, three elements. Select this element and drag it to your untitled one. Okay, and next element you require is nothing but measurements. Okay, in measurement block you require current measurement. So try to keep this current measurement block, as well as you require voltage measurement block. You keep this voltage measurement block also. And now let us try to construct. Okay, so keep it in the mind, we need to construct this diagram. Okay, so otherwise you can do parallelly with me, where you can understand better. So just by watching video nothing you will get, you need to implement this same of your own. Okay, so see here I require three elements. So first what I'm going to do here is, so double click on the element and come to this option. It will shows the branch type as RLC. Just click only R and just click apply button and just click OK button. And what is the element we have is 820 ohm. Double click on it and relabel this resistance as 820 ohm. Okay, so just click on apply. You'll be getting here, and at the bottom if you click you will have a series RLC branch. There you click it as what is that resistor value is 820 ohms. Okay, here you require 820 ohms. So next element you require is 510. Just click on this and use Control C and here Control V. Automatically it will get pasted, and use this button and just you can click it on this right side also if you want to rotate and flip. Okay, so just use this and use Control R, it will rotate. And again copy this resistor. Just you can have these options in by clicking on right hand side. Just you can have copy button and just come to right click and just click on the paste. You'll get this value. Okay, so the value of this resistor is how much as given in the circuit diagram is 510 ohm, and the value of this resistor is 2000. At the bottom you can write down it as 2000 ohm. Okay, so we need to apply some voltage. Okay, so keep this voltmeter here, and now so just see here how I'm connecting. So from the positive terminal just drag it and just connect to this element. Okay, and we need to construct an tree network. Just connect these two circuits, you'll get like this. Okay, and next connect this terminal to this one and connect the negative to the another end of the resistor. So just we can pull it out and the another end of this one to here. Okay, so just very simple. If you use latest, I'm using Matlab 2019B, so this is a little bit good. Go for 2024P, we get more options. So now here you can see here we constructed a T network and you require two voltmeters and one ammeter. In this branch I want to keep an ammeter. Just click on this branch and delete this and use this ammeter, and from this positive you connect to the positive end of the ammeter and the negative, and just you connect the negative. If the connections are correct it will show an solid black color or solid color. If it's showing a red color dotted line indicates that there is a fault in the connection. Okay, so now you need to see the output. Okay, so later we will connect it. So I want to keep connect the voltmeter, so just connect the voltmeter positive to here the positive. If the connection is good it will show like a node. Okay, it's like a node, it is connected. And from the negative you can connect it. It's for the measurement of input voltage. Okay, if the connection is wrong it will show like this. Just drag it back, it will show the exact value. Okay, so that's how we constructed measured the input voltage. And now I want to measure the voltage across this 510 ohm also. Just click on it, just press the right button, just press the copy button and just press the right button and just paste it. You will get the voltmeter here. Just drag it as per your requirement. Just connect the positive to the positive end. If the connection is correct it will show exactly how to move the cursor, then only it will place. And from this negative end move the cursor and you place here, it will get connected. Okay, so you can see the original circuit diagram what we also require. Here also we require the same one voltage source and two voltmeters and the scopes. Okay, so now let's try to connect the scopes. So to connect the scopes, go to the library and in the library scroll it up and come to the click on the commonly used block, and here also you require one multiplier. So for this multiplier just drag the gain and keep it in your untitled workspace. Okay, and next you require scope. So here the scope will be directly available here itself. You can see here whether scope is there or not. If the scope is not there, just you can go to the sinks. Okay, click on the sinks and you'll be getting a display. Just take the display and connect it to it. Okay, so now we want to connect all these things. You can see here in this block the remaining elements what we require is and multiplication and division, okay, to calculate Z11. Okay, so multiplier and division. Okay, so where is the multiplier we need to identify. Okay, so the multiplier you can check it in the, click on the again library. So this is multiplier and division is like mathematical operation. Click on the mathematical operation. You require, you have to have a numerator and denominator. You can see here where the multiplier is there, multiply and divide. Here you have this option, just click it out and bring it out. So now we need to use the master connections. Okay, so just you minimize the library, later you can do it whatever you want to do. So now here let's try to give the connections. Okay, so now I want to connect the scope, connect this current to amplifier, and from the amplifier to display. Use the same amplifier. So here you see here only one amplifier is sufficient to show the current. Okay, and you want to connect the output, use this display and just copy it and paste here. And this is nothing but input voltage. Okay, so this display is nothing but input voltage. This is nothing but the output voltage. So just copy it and paste here and write down it as output port voltage V2. So now just connect it, automatically gets connected. Now just see here, this I will explain you later how to use the multiplier and all these things. So now we have to have an parallelly a power GUI. You can see at the top we have a power GUI. So the input voltage you have to apply is how much? 30. See here I applied 30 here. So you have to apply, click on the source and apply that voltage magnitude as 30 volts and press on the apply. Okay, input only will apply, we just no need to connect the output. So here output we have to make it as open circuit. Just delete that block, and if you want to show it's like an open circuited, just copy this resistor. So just go to here, just copy it and paste here. Okay, and you can see these connections you'll be getting now. So just connect it and then delete this and you just drag it, which indicates that output port is open circuited, input port the V1 we are applying. Okay, just run it. As soon as you run it, you can see here input is 13, output is of 15 volts, and here you are having. Okay, so here also you can see here how much voltage. Okay, so this is 820 ohm. Just cross check the values. This is 820 ohm, this is 510 ohm, and just click on the apply button, and this open circuit branch is 2000. Okay, so just type it as 2000. Okay, just click on the apply button and OK button here. Okay, so just once again go to file and save it. Okay, so we are okay, while saving you have to see that, so you have to keep what is the name of the circuit is jet parameter for YouTube. Okay, just I'm doing for your YouTube purpose only. Just I'm saving in my folder whatever I want to save it. Okay, in YouTube demos I'm saving, so it will get saved here. Just click on save, it will get saved. Okay, so there should not be any space or something else, the file cannot be saved. Okay, so after running it, you see here the basic thing behind here is, so here we are going to have the basic equations as like this. Okay, so we have the basic equation v1 is equal to z11 I1 plus z12 I2, and second equation is v2 is equal to z21 I1 plus z22 I2. Okay, so here initially we'll make as I already told, output port I2 is equal to 0 here. When you make I2 is equal to 0, then we are going to find the values of z11 as well as z21. Therefore z11 is equal to v1 by I1. What is the value of z21? So z21 is equal to v2 by I1. Okay, so next I require z12 as well as z22. So I want this value, this parameters have to make it as 0, which is nothing but I1 is equal to 0. Whenever I1 is equal to 0, then I am going to get the value of Z12 is equal to V1 by I2 and the value of Z22. So the value of Z22 is equal to V2 by I2. So we are going to get V2 by I2 and we are going to get this block. Okay. So now we can see here. So initially this we are doing now. Okay. So output port is open circuited. We require the ratio of V1 by I1 and V2 by I1. Okay. So now let us try to demonstrate that one only. So we require, so just I am keeping it aside for your clarity. So we require only V1 by I1. So I2 output port is open circuited and we require V1. This is V1 and this is nothing but I1. Okay. So here this is in directly in amperes, but I want to express in milliamperes. Multiply this value also with 1000. The resultant will be in milliamperes. Okay. So multiply this with 1000, then you are going to get the current in milliamperes. Okay. So just keep it as 1000. Just click on the apply button and just click on the OK and just save it and just go to file, just save it and again click on the run button. The current has been converted into milliamperes. Now this current will be in terms of, so input port current, which is nothing but I1 I1 is equal to I1 in terms of milliamperes. Very simple. That's why I multiplied this with 1000 also. Okay. So now you can understand better. So now I want the blocks of numerator should be V1. Where is V1? Here it is V1. Okay. So now just use one button, drag it and keep it there at V1. So if you have any confusion, you can move it out. So this is V1. Okay, and you require I1, V1 by I1. So in the denominator I require I1. So no need to write down the 1000, right? Just initial input only we need to connect. So just drag it down and keep it to this terminal. Okay, so then now we can understand better. Okay, so now this is I1 I have been connected. So this is V1, numerator is V1, denominator is I1. So it will get V1 by I1 and I require this block. To display this, I'm once again copying this source, Control C, and you just paste here, just paste it, you'll get the block. You'll get the block. Just click on it, automatically it gets connected. Now it will show the value of Z11. Just run it. It will show the value of, it is 1300 ohms. Okay, so this is what the value you also got in the original circuit diagram also. So when you run it, it is also 1330 ohms, and this is nothing but output voltage V2. Why? Because this is open circuited. So again you want one more block, just copy this, just use right click and just copy it and paste the another block. So this value is nothing but Z11, Z11. Okay. So again, just right click it, copy it, and paste it. And we require the next ratio. What we require is V2 by I1. Where is V2? This is V2. Okay. From this we require V2. Okay. So to the input block we require. So just connect it here. Okay. Just keep it like this. This is nothing but V2 divided by I1. Where is I1? This is nothing but the original I1. Okay, so you can connect it and divide this with I1. Okay, so see this derivation, you can understand V2 by I1. And once again use this scope, copy it, and once again paste here and just connect it. And this is the value of Z21. Okay, so this is Z21. Okay, once again after completing all the tasks, go to file and save the file. Okay, save the file. You can see here output port is open circuited. Just run it again. Okay, So it is showing the beauty is nothing but Z11 is 1300 ohm, Z21 is 510 ohm. Okay, so you can see the original circuit also. Z21 is how much? 510 ohm. This is 11.5 ohms. This is how I have done the making the port. So if you want to give the name, just copy all the blocks, just move it down and write down here output is open circuited. Okay, so now same you have to construct by making input as open circuited and remaining you have to do here. Okay, so for this I'm copying the same circuit, just copy the same circuit, use just Control C and come down. So here you got the circuit diagram. So here input is input port is open circuited. So here input you have to make it as open. So how to construct the diagram also I will show you here. So this is first one is completed and second one we require here. Okay, so here just we need to exit from this source. So what we'll do is let us try to remove all these elements. Okay, so first remove the elements. Okay, so this also I'm deleting, this also I'm deleting, not required, this also deleted, and this voltage source is also not required. Remove this one and remove this voltage source, this also. And now we want to give the voltage here. Okay, so how to give the voltage is very simple. Just take the voltage source from here, just copy it and paste here and connect the positive to positive, negative to negative. Okay, so you'll get an error, just click it, automatically you'll get. And here you are making the output port as open circuited, and now let's try to remove it. Okay, so in order to show that, just copy one element, just use copy and paste that element here and just connect a terminal to this one and delete this element and drag it. So now these two elements are also not required, just delete it. This also you can delete. So now you can see here which port we are giving input is. So input we are applying the voltage and we are measuring the output. Okay, so we are exciting only the input port and this value is same 2000 ohm, 500 ohm, and this value is 820 ohm. Okay, so just give those values and now let's try to construct whatever we want to do it now. Okay, so you can see the circuit diagram for reference. So this is what we need to do the simulation. Okay, so we need to connect it. So we require one voltmeter already connected, so just take the voltmeter and ammeter. Okay, at output side you require the current, so therefore you take the ammeter from the circuit. So this is ammeter, copy the ammeter and place the ammeter here. So remove this connection diagram and keep the ammeter. Just use right click and paste this signal and rotate this. Okay. So to rotate here, you can directly use how to rotate also. So just use this right click and just press Control R. It will rotate automatically. So connect the positive to the positive and negative to the negative. Okay. And here you require the scope. So this is Control C, Control V, and just rotate this one also. So let's try to keep it here. So current is available. Okay, so now let's try to see what actually we need to design. So we have done the same, almost all set to complete. So we excited with input voltage and we are measuring the current I2 and the voltage. Okay, so voltage is this is nothing but input, not output voltage. Now this will act as an input voltage, and this is the current. So now we will remove this one also. So just run it. So it will show that how much you applied, 30 volts. Okay, so in order to show this voltage, we'll connect one voltmeter also. Okay, so just connect one voltmeter, connect positive to the positive, negative to the negative, and here you require an scope. Okay, so just take one scope and connect to the scope here. Automatically it gets connected. So how much we are going to apply this side is 30. So now let us try to see the derivation formula, what we had done here. So we require V1 by I2. So this is nothing but V1 and this is nothing but I2. So now let's try to use this block. Okay, so now take this block. We require V1. Okay, V1 by I2. Where is V1? This is V1 value. Okay, so just keep it in the input side, V1 by I2. Okay, so this is nothing but the value of so you can reduce the size if you want to do it more. So we require V1 by I2. Okay, so this is nothing but V1, I2 is this one. Just drag it and connect here. So this is nothing but the value of I2, and just connect to one scope. Okay, so this value will be Z12, Z12, and next we require Z22. This is the value I require, Z22. Z22 means V2 by I2. Where is this V2 by I2? Here I have the V2. Okay, so just move these two blocks. So V2, this is the V2 value at the numerator, V2 by I2. I2 means this is nothing but output port. Just connect this to the output port, or you can directly connect here. Okay, so now this will give the Z22 value. Just see the original diagram, you will get an clarity. So the original diagram is like this. We require Z1, 2 and S510 and 2500. Okay, so just run it. Okay, so you are going to get it as Z12 as 500 ohm and Z22 as 2500 ohm. So here what I can say here is, so later you can adjustment however you want. So input you are making open, output you are applying the voltage. But in the previous circuit, when you see here, so we have done in the reverse. Okay, so input we applied, output is open circuited. That's how we got Z11 as well as Z21. But here we are doing in reverse. Okay, so Z22 means V2 by I2. This is V2 and this is nothing but the I2 value. So here this is nothing but Z12. Where is this V1? V1 is here. So this is, we applied 30 here. So from 30 of the loss from 2000 ohm, so you can replace these values as 2000. So this you can do as per your interest. Okay, so it is reduced to 6 volts. So this is nothing but V1 by I2. This is nothing but V2 by I2. So if you understand this formula, then you can understand the things. This is the second one what we have been implemented for the understanding. Okay, so this is all about the evaluation of Z parameters. Just run it, you'll get the values as a 510 ohm. Okay, so ultimately the values, just you minimize it, then you can see complete diagram. So Z11 is 1300, Z12 is 510, Z12 is 510, and Z22 is, you can see here, Z12 is equal to Z21, both are in symmetry in nature. Okay, so Z11 and Z22 are different, where Z11 and Z2 is different, where they are not symmetrical in nature, but these are in reciprocal in nature. That's how to validate your result. Just try it, just by seeing nothing you get. Just see the YouTube content and keep parallel screen and do parallelly of your YouTube. Then you can get the results. Hope you are able to understand. So if you feel the content is useful, please like this video and share with your friends, those are doing the same content or those are studying the same subject. If you have any doubts, let me know in the comment section. I'll answer your comments. And if you're watching this channel for the first time, subscribe to my channel with the name KV Tulasi Ram, and kindly encourage these sort of free channels where, so before watching this video you can see the hardware results also. Okay, hardware, Matlab, as well as theoretical calculations, all three are available. Okay, so these are the free contents available in online. So kindly support this sort of free channel for the development of students and faculty. Okay, so this video is meant for three variations. Okay, so here we are validating with respect to theoretical calculations, one video is there, hardware one video is there, and simulation also another video is there. So thank you for watching. We'll meet in another video.